So the type of analysis we're interested in is growth analysis. So extending the analysis beyond just reporting means and differences in means for cohorts of students, and actually modelling individual growth. Okay, so we'll be talking about the analytic extensions to our analysis, our modelling, and we do this using multi-level models for longitudinal NAPLAN data, and then I'll talk about the results for reading and writing growth. So at this point, I want to acknowledge, in addition to Joy, who's been working on this data, Professor Harvey Goldstein, who's a professorial fellow here at the Institute, based in London. And Harvey's just been out here to visit, so we've done a lot of work on advancing our modelling. And Dr. Melanie Spellick, who's here today, who also works in the data analysis team and is working on these models. So with the NAPLAN data, we do have scores for children from a cohort that's linked over time. Okay, and as Joy said, the analysis I'm going to show you today is just on the Year 3 cohort from 2011, and we're looking at growth through to Year 5. So we can do analysis that looks at longer periods of time through to Year 7 and Year 9, and we're working on that analysis at the moment, but we're just reporting the growth from Year 3 to Year 5 today on reading and writing scores. And these are the total scores for reading and writing recorded in NAPLAN. The analysis that's generally reported is univariate analysis, so it just looks at change over time for subgroups. Okay, so it might be comparing change for Indigenous and non-Indigenous groups, girls and boys, and so on. Children that live in rural and remote areas to children that live in metropolitan areas. But we really need to really capture the variation in growth across students. We need to be able to capture all of those factors at once and how they impact on change in scores. So how can we do that? Well, we can do that with multivariate analysis in the form of multi-level models. So these multi-level models capture different sources of variation. So they're called multi-level because they look at variation sort of in the education context. We can look at variation of students within schools and variation between schools. So in this sense, we have two levels of data. We have data at the level of the individual, and we have variation at the individual level. That might be the result of lots of different circumstances for a child, and we also have variation at the school level. So there are lots of factors about a school that will impact on the outcome for a child and the growth in achievement for that child. So our multi-level models allow us to do this and capture change over time, but it also does a number of other things. We can estimate the effects of variables at both school and individual level. So we can capture aspects of the school and how that impacts on growth if we can measure that. Now if we don't have measures at the school level, we have a few measures in NAPLAN data, but not a lot. We're at least able to partition out the variation due to the differences in schools, and so that we can then better estimate the effects of factors or variables associated with the child, such as their family circumstances, education of their parents, where they live, and that type of thing. So in NAPLAN data, as in most longitudinal data, there are also missing observations for many reasons. So we want to estimate growth from Year 3 to Year 5, and we're able to do that because we can link we have a student ID that links the data from Year 3 to Year 5. There may be data missing, say, at the Year 3 level, but we have data at Year 5. Okay, so rather than discard data on those children, we can impute observations. And we can also incorporate measurement error. So when the total score is estimated for reading and writing, this is computed from the various items that are tested, and there's measurement error involved with combining those items, so that's another source of variation. So we can control for all of these sources of variance and then, you know, estimate the factors that affect the growth in scores and achievement for individual students. Okay, so I've just added the equation here for those who might be interested, but basically we're estimating Year 5 scores, we're controlling for explanatory variables that you'll see a list of these in a moment. That may be sex of the child, location of the child, you know, where they live in remote, the geolocation, whether they live in rural remote areas, metropolitan, so forth. And we're also controlling for the Year 3 score, so that allows us to estimate growth in addition to where they were at Year 3, and we have an effect for the school. So if this is an effect due to the school that they go to, and then we have sources of variation associated with the child that we can't measure through the factors that we have in the model or in the data. Okay, so it allows us to control for lots of different sources of variation. So this table shows the results from the model for reading progression. So the reading progression analysis that we've done here comes from data that was obtained from ACARA. So we have a sample size of over 53,000 students in this analysis. Okay, also the data has been normalised at Year 3 and Year 5, which just really means that we're sort of normalising the data around a mean of 0. Okay, so then we can look at progress in terms of whether a child sort of stays above the average from one sort of testing period to the other, falls below average, or so on. Okay, so what these results are showing, and I'm going to show you this, talk about it in words and show it to you visually, but really the highlighted numbers here are significant results. So this result here is interesting, as it actually is different to what Joy said before about girls doing better in reading from Year 3 to Year 5. You can see we have a negative coefficient, which means after controlling for all these other things, on average they do slightly worse. But Indigenous females do better than Indigenous males. So you can see by including multiple factors in the model, we can control for various impacting variables together. And so the results might be slightly different to what you would see if you were just looking at changes in averages. So another interesting result here is that the Year 3 score is included in the model because we're interested in growth, so we're controlling for the previous score. And it's actually, there's a non-linear relationship. That's what these extra squared and cubed terms mean. So the relationship between Year 5 scores and Year 3 scores in reading are not linear, which just means that the change will be dependent on whether the Year 3 score is low, medium or high. Okay, so there's not a linear change across for all children. Okay, and the language other than English variable, which is a dichotomous variable in this analysis, it just has two values. Sort of language spoken at home is English or not, and reading tends to be lower for language other than English at home, spoken at home. Okay, and then there's the Indigenous by rural effect, where Indigenous students in Year 5 growth the growth rate is lower over time than for Indigenous students in non-rural areas. Okay, and we also get these variance estimates as well, which is, they're both significant, but this is saying that after explaining for all these individual level factors or student circumstances, that the variation between schools is still significant, so there's still a school effect, even though we can't explain what it is. And usually what we find with this type of student data is that the variation among students within schools is much higher than the variation between schools. Okay, so the contribution to unexplained variance by schools is about 7%, but it's still significant. Okay, so just summing, this is summing up in words what I just said. So there's overall a positive progression on average of reading scores from year 3 to year 5, after the adjustments by subgroups. But progression occurs at a lower rate for Indigenous students, for girls, and students who are elbowed. Okay, Indigenous students in rural remote locations progress at a lower rate than Indigenous students in metropolitan or provincial locations. Okay, and to show that graphically, so we've produced these graphs here, which are based on the model predicted growth from year 3 to year 5. This graph is for boys, this one is for girls. Okay, and the lines show growth patterns for different groups. So the blue line here is for Indigenous students in rural areas. The next line is Indigenous in metro areas or non-rural areas. And then we have the non-Indigenous groups for boys and girls. So we've only controlled, the graph only shows students who achieved an average year 3 score in reading. So this shows the progression on average from year 3 to year 5. Okay, so that's the overall average. We could have produced these plots for different year 3 scores, year 3 scores above average and below average, and they would have given you similar trends, but the slope may not have been, would not be exactly the same. Some would be steeper, some would be shallower. But this just shows you, remember, the predictions for the average student, and in reality we can actually produce growth for all individual students. They'll be different, they vary around the average. Okay, but first of all I'm going to talk to you now about the writing progression results. So for writing, this is the most recent analysis that has been done, and it was using data from the Queensland Department of Education, and only contains government schools, results for government schools. So we have 36,000 students, which is less than the number of students we had for the other data, which was across all school sectors. So again, this is the variables are presented in a slightly different order, but we had, so we still get the non-linear result between year 5 outcomes and year 3 outcomes, so the growth in writing scores. This time, Indigenous students have a lower progression than non-Indigenous students. This time the female progression is a lot higher than males, has a coefficient of 0.2 rather than 0.06, I think it was. And the students classified as elbowed actually have a higher progression than those who are not in writing. Okay, and we still have the Indigenous by geolocation interaction, where Indigenous students in rural remote locations have a lower progression rate than, or lower growth rate than Indigenous students in other locations and non-Indigenous students. Okay. So this is just summing up those results. I'll move on, and we've produced similar graphs, and so you can see here that we still have progression on average for students that are different for the same 4 groups, but the spread is wider for writing. Okay, so the rate of growth differs more for writing for these different groups, if that makes sense. Okay, and you can see that the overall, so the mean in writing the mean of the writing score in Year 5 is higher for girls than boys, and these are the growth patterns for boys and girls. Okay, so just to emphasise this issue about variation in growth for students. So the solid lines that we saw before are the average growth rates, but because we have terms in our model that capture variation between students and variation between schools that aren't explained by other factors, we can actually capture that variation in growth by students. So the blue line is similar to the lines on the other graph. This is progression for Indigenous girls in rural remote areas. And these other dashed line shows the possible growth rates for girls in this group. So the solid line is the average growth rate, but our model tells us that 68% of girls in this group actually have growth that varies between these points. Okay, so we can actually look at patterns of growth for the students in these, different students in these subgroups, rather than just talk about the overall average all the time. Okay, so it will, modelling data in this way can give us a sense of the extent of variation and can help us we'll analyse the patterns and predict growth for different types of students. Okay, so as I said before, this is just our initial analysis looking at change or growth from Year 3 to Year 5 in reading and writing, and we are able to do that then for the Year 3 through to Year 9 data. So we can actually look at what's the growth from Year 3 to 5, and can we use this then to predict what the outcomes are then going to be in Year 7 and Year 9 for different students. Okay, so in summary, we can use multivariate, multi-level models to better predict growth. We don't just have to talk about change in averages for different subgroups of cohorts. The variation is modelled at 2 levels, both the school and student level, and if we had more school level data in our data sets, we could actually try to explain some of that school variation. We can also take care of missing data in our models and variation due to measurement error. So we don't have to ignore all of our students where we have some missing data, which is often done when computing averages. Our directions in analysis will be about understanding the growth patterns in writing scores of students and the different factors that impact on individual growth. We're looking at, we are developing models for non-linear growth in student writing scores from Year 3 right through to Year 9. So, so in light of that, I would like to, invite further discussion with you and welcome any contributions to this work if people are interested.